Hey class, today we're going to be doing section 10.2, which is the hyperbola in our conic section chapter. In the last lesson, we did the ellipse. This is going to be really similar. It's going to look almost the exact same in the formula. There's one major difference, which is this piece right here. So we still have the x minus h squared over a squared. We have the y minus k squared over b squared. It always equals 1. And so a lot of this is the same. Always equals 1. We have the same center, same way to get away from our center, but this here, the biggest difference in the equation is the minus subtraction sign. So look for that. If there's a subtraction sign, then it's going to be a hyperbola and not an ellipse. Now, graphing, it's also going to be a little different. The vertices and the direction that it opens, so our hyperbola either opens to the side or it opens vertically, and the direction that it opens is based on which part of our equation is positive, or which one comes first. So if the x part comes first, so x minus, let me see, how should I say this? X part is positive or comes first in our equation. So if the x part comes first, then our transverse axis is going to be horizontal. Our vertices are going to be the 2 points horizontal from the center, and the hyperbola is going to open horizontally. If the y part is positive or comes first, then our transverse axis is going to be vertical. Our vertices are going to be vertical. It's going to open vertically. So it's all about which one comes first, which one's positive in the equation. All right, and then we're not going to worry about the focus for hyperbolas. We are going to use the focus in the next lesson, which is the parabolas. But for right now, we're not going to worry too much about it. So let's do a couple graphs, and I'm going to let you do a couple on your own and check them on our course calendar. So here, x squared over 16 minus y squared over 9 at the center is at 0, 0. And my a value is 4 in the x direction, b value is 9 in the y direction. And because x comes first, it's going to open horizontally. So it's going to open this direction. So 0, 0 in my center, 1, 2, 3, 4 in my x direction, 1, 2, 3, 4, negative 4 in my x direction, 1, 2, 3, and 1, 2, 3 in the y direction because it's underneath the y value. Now graphing this, we're not going to make an ellipse. This is where it gets different for the graph. We are going to make a dashed box around the points we just found using A and B. Then, and I'm going to use a different color. You don't have to. We are going to draw our asymptotes. So our asymptotes are going to be the diagonal lines that go through the corners of our box. And this is going to be what dictates how wide our hyperbolas are going to open. So you want to make sure to make those asymptotes nice and big so that you have room for your hyperbola. And then the hyperbola, so again, it opens horizontally because x part came first. So I'm going to use the 4, 0 as my vertex, and then this is going to open towards the asymptotes. Make sure not to touch them, just go towards them. And then on the other side as well. So if the asymptotes were more narrow, then this would be more narrow, and so forth. So the asymptotes figure out how wide our hyperbolas are going to be. Let's do, I'm going to skip to part D. So here our center is not at 0, 0. It's at, and now we have to be really careful. The x coordinate has to come from the x part of the equation, which is actually second. So be careful. The horizontal piece, x minus 3 squared, means our center is going to start at 3 in the x direction and 5 in the y direction. So 1, 2, 3, 1, 2, 3, 4, 5. Oh yeah, this one, I didn't do this very well. So I'm going to count by twos. which is going to get a little weird, but that's all right. So 2, 4, 6, 8, 2, 4, 6, 8. So just because it doesn't fit well if I don't. So 1, 2, 3, 1, 2, 3, 4, 5. So there's 3, 5. Now my A value in the X direction, it's going to go 5 in each direction. In the Y direction, it's going to go 2 in each direction. So 1, 2, 3, 4, 5. Remember, I counted by twos. 1, 2, 3, 4, 5 in the X direction, and 1, 2, and 1, 2 in the Y direction. I'm going to make my box with dashed lines because it's not actually there. It's not actually part of the hyperbola. The only part that's technically part of our graph are the curves, but we still want to see all the other pieces so I can make sure you're doing it right. You can make sure you're doing it right. So definitely show everything. And then my asymptotes, let's see, we've got through the center and the corners of our box. And then which direction is it going to open? Well, it's the Y part comes first, so it's going to open vertically. So here I'm going to have a really wide hyperbola. And down here it's going to open up and down. All right, so there is that hyperbola. Another thing to note, you will be asked a couple questions in this chapter on the asymptotes and specifically the equations of the asymptotes. So to get the equations of the asymptotes, you know what, I think we're going to do it on the next page because we have a little bit more room to work with. But I do want you to be able to get the equations of those lines. All right, rewrite the equation in standard form and graph. So remember, we need this needs to be 1. So the first thing I'm going to do, I'm going to take my y squared minus 4x squared equals 36, and I'm going to divide everything by 36 to get it to equal 1. So y squared divided by 4 minus x squared over 9 equals 1. This one has a center at 0, 0. My A direction in the X direction, I always like A to represent X. I don't know, it doesn't really matter as long as you do it right on your graph. B is 2, and it's going to open vertically because the Y part comes first. The Y piece is positive. Now the asymptote equation, and now this takes some practice if you're not super familiar with lines and equations of lines. I would suggest graphing it first and then using the graph to get the equation. So first my center is at 0, 0, and then I have A is 1, 2, 3 in the X direction, 1, 2, 3, 1, 2 in the Y direction. Draw the dashed box there, rectangle, and then my asymptotes are going to go through the center. Now the equations of these asymptotes are going to be a little bit easier because they're going through the center. Okay, so the asymptote, if it goes through the center, I'm going to have y equals, now I'm going to put, well, I'm going to list them twice. So one of them is a positive slope, one of them is a negative slope. The slope, if you think about where the center of your box is, it goes up 2 and over 3, just like the box. We went up 2, we went over 3. So my slope is 2/3. In the negative direction, it's down 2 over 3. So it's negative 2/3 x. And then in this case, there's no y-intercept. So if there were, I could put plus, and then wherever my asymptotes were crossing the y-axis, but here I don't need to, so that's good enough. There's my lines. All right, and then it opens vertically, so it's going to open like this. And on the bottom, try to follow those asymptotes, that's why they're there. Find the equation in standard form of each hyperbola. So this one has a center at 0, 0. I'm going to let you try to do A after we do B together. So here, the center is at +2, -3. And it's opening horizontally. So my x piece is going to come first. So x minus 2 squared minus y plus 3 squared, remember it's the opposite signs, equals 1. And then I have to figure out what my denominators are. So in the x direction, I'm going over 2 in the x direction, so 2 squared is 4. And in the y direction, to the top of the box, and it's a little hard to see, so I'm going to go down here. So I can see the box ends 1, 2, 3 down from my center, so that's going to be a 9. All right, and then the last problem here, convert the equation into standard form by completing the square. So we did this with circles, we've done it with ellipses, we've done it with parabolas a long time ago. So now with the hyperbola, again, really one of the only differences between this one and the ellipse is that there's going to be a negative involved with one of our variables. So the first thing I want to do is get all my variables grouped. So the x's grouped together, 24x, and then we have minus 25y squared plus 250y, and then I'm going to bring this one over equals positive 489 because I'm switching the sign as it moves over the equal sign. Now I need to factor out the a values, so 4 times, and I'm going to make this a little bigger so that I can keep it within the box here. So 4 times x squared minus 6x plus blank. And then I need to factor out the negative 25 from the y squared. And when I factor out the negative 25, it's going to change the sign of this one to negative 10y plus blank equals 489 plus blank plus blank. All right, so to balance those out. Now I have negative 6 over 2 squared is negative 3 squared, which is 9. So I'm going to put 9 here, but then that's not really a 9. It is a 4 times 9, which is a 36. So I need to balance that out by adding 36 to the other side of my equation. And then we have negative 10 divided by 2 squared, which is negative 5 squared is 25. But then remember, that's not really a negative, or it's not a 25. That is negative 25 times 25, which is a negative 625. Negative 625. So that's what we need to balance it out with on the other side of the equal sign. Remember, because they're on both sides, I'm balancing it out on this opposite side of the equal sign. I want the signs to match. Think like a teeter-totter. I want them to be equally weighted so that they balance each other out. Now I have 4 times x minus 3 squared minus 25 times y minus 5 squared equals, and then 489 plus 36 minus 625 is going to be negative 100. Now for the next step, we need it to equal 1. So I'm going to divide everything by negative 100, and this step gets a little different. When I divide by negative, the signs are going to switch. So now instead of the y part being negative, that piece, negative divided by negative, is going to end up being positive. So I'm going to switch my variables so that the y part, the positive part, comes first. So we have y minus 5 squared over 4 minus, so 4 divided by negative 100 makes that x piece negative now. So x minus 3 squared over 25 equals 1. So be really careful about dividing by that negative. It's going to switch the signs. You'll want to rewrite them in an opposite direction so the positive piece comes first and the negative piece comes second. And then you can try the next equation here. You can pause the video. I'm not going to do all the work, but I will give you the last answer in case you're not in my class, but you're still looking and following along. You should end up with y plus 5 squared divided by 4 minus x minus 3 squared over 9 equals 1. So it's really similar to the other one when you work that out, but it's always good practice. All right, and that's it for today's lesson.